Good morning. Today we're going to talk about how to do one-step mole conversions. We talked about this briefly on Wednesday, or y'all actually practice doing gram to mole and mole to gram. Today we are going to talk specifically about going from moles to atoms or particles or molecules, and then from atoms, particles, or molecules back to moles. So there's still only one-step conversions because we are only using the conversion factor 1 mole equals 6.02 times 10 to the 23rd atoms. And here where it says atoms, you could substitute the word particles or molecules. And this number is also known as Avogadro's number. Okay, so I have an example for you. Our first example asks how many molecules are in 3.6 moles of MgCl2. So I'm starting with what I've been given. This is my given, and this is what I'm being asked to find. So I'm going to go ahead and write down what I've been given, which is 3.6 moles of MgCl2. It's a one-step problem, so I'm going to go ahead and draw my framework and just use one line. Okay. We said what we are trying to find always goes on the top right-hand corner. So I'm going to go ahead. This is what I'm trying to find, molecules. So I'm going to go ahead and write that in the top right-hand corner. Molecules of MgCl2. Go ahead and extend my line a little bit. On the bottom, we said whatever unit we started with here had to kind of shift down because we had to divide by it. So we're dividing by moles of MgCl2 in order to get rid of moles of MgCl2. Now, last time we used molar mass because we were going to grams or from grams. This time, however, we're not talking about mass. Okay, it doesn't ask us about grams, so we are not going to use this to find the molar mass. Right now, when we're going from moles to molecules, we are simply going to use this conversion factor. 1 mole is equal to 6.02 times 10 to the 23rd atoms, or in this case, molecules. So down here where we have the word mole written, we're simply going to put 1, because I know that 1 mole is equal to, and up here where we have molecules written, we're going to use Avogadro's number. 1 mole is equal to 6.02 times 10 to the 23rd atoms, molecules, or particles. Okay? In order to solve this, we're going to do the same thing we did last time. We're going to multiply across the top. So 3.6 times 6.02 times 10 to the 23rd divided by 1. Now, whenever you type that into your calculator, you're going to have to use a little exponent button. Okay? So if you have the calculator like this, only they're yellow, that the school has, that they provide for you, you're going to turn it on. You are going to do 3.6, so 3.6 times... And then you're going to do 6.02 times 10 to the 23rd. And the way we're going to do that is 6.02. The way you get the times 10 is you see this EE up here. The capital E is calculator speak for times 10. So you're going to hit the second button. You see how it makes the cursor blink? And then you're going to hit the comma button. And we get a times 10. So that is saying 6.02 times 10, and now I'm just going to type in 23 for the 23rd power. All right? At the end of that, I hit enter. This is my answer. This is, so we can see better. This is my answer. And we're going to round to 2 places after the decimal. So my answer here is going to be 2.17, but you cannot leave off this E24. Okay? Because if you do, then that's saying you have 2.17. Molecules, when in fact you have 217 with 22 zeros behind it. You have a very, very large number of particles. Okay, so we cannot leave off this part right here. That's where a lot of people go wrong. Okay, so we're gonna go ahead and write down our answer. Our answer is, get back where we can see it, equals 2.17 times 10 to the 24th. Notice I did not write the E here. I wrote times 10 again. And then we're going to have molecules of MgCl2. Okay? Simple enough? Again, it's just one step because we're just using one conversion factor. I put the thing on the bottom that I'm trying to get rid of, and the thing that I'm trying to go to goes on top. Okay, so example number 2. Example number 2 asks us how many moles are in 4.8 times 10 to the 24th atoms of Fe, of iron. So I'm starting with 4.8 times 10 to the 24th atoms, and I'm trying to go to moles. Again, I'm going from atoms to moles, and it's a one-step problem because I have a conversion factor up here that has moles and atoms in it, so it's just one step. Okay? This conversion factor has both atoms and moles in it, so it's a one-step problem. So I'm going to go ahead down here, I'm going to set up my problem, and I'm going to start with what I've been given. I have been given 4.8 times 10 to the 24th atoms of Fe. I'm going to go ahead and set up my framework, and since it is a one-step problem, I'm only going to draw one line. Okay? We said we put on the top right what we're trying to go to. In this case, it's asking me how many moles. So I'm going to go ahead and put moles of Fe on the top over here. And on the bottom, we have to put the unit that we're trying to get rid of. So we started with atoms. So we have to divide by atoms in order to get rid of it. Now, in order to figure out what numbers go here, I look back at my conversion factor. What I know is that 1 mole is equal to 6.02 times 10 to the 23rd atoms. So I'm simply going to plug that in down here. Where it says moles, I'm going to go ahead and just put 1. And where it says atoms, I'm going to go ahead and write Avogadro's number, 6.02 times 10 to the 23rd. Okay? Now, solving this works the same way. We're going to multiply across the top and divide by the bottom. In this case, the 1 is not on the bottom, so we have to divide. So we have 4.8 times 10 to the 24th times 1, which is just 4.8 times 10 to the 24th, divided by 6.02 times 10 to the 23rd. So, go ahead and plug that in my calculator. I'm going to use parentheses in order to show my calculator order of operations. I have 4.8, hit my second comma button right here to get my EE, my times 10, to the 24th power, divided by, open parenthesis, 6.02, hit my second comma button, the times 10, 23rd power. Enter. Notice my answer here is a much smaller number. It's not times 10, okay? It's just 7.97 and then all this extra stuff. We're going to round to 2 places out the decimal, so it's just going to be 7.97. All right? Let's go ahead and write my answer down here. 7.97. My units are moles, and my substance is iron, Fe. So my answer here is going to be, I have 7.97 moles of Fe in 4.8 times 10 to the 24th atoms. Okay? So today you are going to take this information, just this one-step problem, and you're going to do the 12 problems that have been given to you by the sub. And again, it's just one step, so we're using 1 mole is equal to this many atoms. And you're either putting, if it's up here and you're starting with moles and going to molecules, then Avogadro's number goes on top and 1 mole goes on the bottom. If you're starting with atoms and going 2 moles, then 1 mole goes on top and Avogadro's number goes on the bottom. Okay, so everything you're going to do today is going to be set up one of these 2 ways. All right? Please do it. Please show your work so that way if you make a misstep, we can see where you go wrong. And you're going to turn your work into the sub. Make sure you put your name on it. Claim your work. Okay?